So the last topic that we are going to talk about with this trig unit is the law of sines, and then we will next do the law of cosines. Today we are going to focus on the law of sines. Okay, and basically the law of sines is one way that you can use trig to find sides and angles when it is not a right triangle. So everything that we've done up to this point has been right triangle trig with opposite and hypotenuse, opposite, adjacent, all of those things. Now we are going to look at triangles that are not right triangles and a couple of ways that you can still use trig. One of them is the law of sines. And basically, if you look right up here, the law of sines is just a series of ratios. So you'd have the sine of A, of angle A, divided by A equals the sine of angle B divided by side B, and the sine of angle C divided by the side C. Or the other way is if you just flip everything around. And the reason that we have both of those, they're the same formula basically, but it's a matter of where your unknown value is. So here in a second I'll talk more about that. So in order to use the law of sines, you need to have an angle and the side opposite of it given to you. Okay, so that's one important piece of information. Some other helpful hints are that we are no longer thinking of sine in terms of opposite and hypotenuse. We don't have a right triangle, which means we don't have a hypotenuse anymore in the triangle. So basically you're going to set up and solve proportions. So even though up here it has three ratios, sine of A over A, sine of B over B, sine of C over C, you're only using two at a time. So you're going to use one pair of side and angle and another pair of side and angle. Each side of the equation is always a matching side and angle. And this helpful hint right here, if you put your unknown or your variable that you're trying to solve for in the top, it makes it easier to solve. So that's what we're going to talk about as we start to move through this. Okay, so we are going to use first, I have two examples of how we can use the law of sines to find a side length. Okay, so, and we want to think about, we want the missing value to be in the numerator. Again, that makes it easier to solve. So right now, we look and our missing value, x, is a side length. Since our missing value of x is a side length, we want that side length in the top. So we are going to be looking at the proportions that have the side length in the top. So what we're going to do is we're going to have every one of these is just an side and the sine of the angle opposite of it. So we have angle A and x are opposite of each other. So we are going to say that x over the sine of the angle opposite of it, which is the sine of 33. Okay, so that's our first pair. That's our one side of our proportion. And all we have is a side and the sine of the angle opposite of it. And then the other one, we have 81 and 26. So we are going to put, again, the side in the top. This is going to be the other side of our proportion. The side in the top and the sine of the angle in the denominator. Okay, so this is where I talked about why it was easier if we have the x in the top or the missing value in the top, because if we have x here, all we need to do to get x all by itself is multiply both sides by the sine of 33 in this case. So I'm going to multiply times the sine of 33. Those cancel and I'm just left with x equals, and this all here is what you're going to put into your calculator. 26 times the sine of 33 divided by the sine of 81. And it's important as you're doing this video that you go to your calculator, practice putting that in there, because sometimes with parentheses and different things with calculators, it's easy to get the incorrect answer. So go to your calculator, do 26 times the sine of 33 divided by the sine of 81. Notice that we have the sine of the angle and the sine of the angle. It's not just 33 and 81, it's the sine of 33 and the sine of 81. And when you put that into your calculator, it tells you that x equals 14.3. Okay, I'm going to do one more example where you have a side length that you need to find on the next slide. Okay, so here Basically, it's a little story problem that goes along with it. A surveyor makes measurements shown to determine the length of a bridge to be built across a lake. So C here, this is the length of the bridge that they are building. Okay, so that's basically what we are finding. So it's going from the north picnic area to the south picnic area. We need to find the length of C so we know what the length of the bridge is. Again, we are using these here, A, B, and C on top, not sine of A, sine of B, or sine of C on top, because our missing piece is a side length, okay? And we want our missing value to be in the numerator when we go to solve. So if we look, all right, so we've got C and 60 are across from each other, and then we have 49 and 150 are across from each other. So we're going to have C divided by the sine of 60. That's our side length. There we go. Our side length divided by the sine of the angle opposite of it equals, okay, and our side length is going to go on the top, so we'd have 150 over the sine of 49. So we have side length divided by sine of an angle equals side length divided by sine of an angle. Now, when we go to solve this, we like to have that missing on the top. That C is in the numerator. So that way, all I need to do is multiply both sides to get C by itself. I'm going to multiply both sides by the sine of 60. They cancel over here. That just leaves me C. Then in your calculator, you're going to have 150 times the sine of 60 divided by the sine of 40. Again, just be careful when you're putting that into your calculator to make sure you have the sine, everything in there, and you should end up at, the length of the bridge is going to be 172.1 meters. Okay, so we can use our law of sines to find a side length of a triangle that is not a right triangle. That's a couple of examples of that. Now we're going to, in the next two slides, look at examples where you can use the law of sines to find angle measures. So let's look at that. Okay, so how can I use the law of sines to find an angle? Well, I want to find angle B, it says. Oops, sorry about that. I meant to highlight. We want to find angle B. All right, so here's angle B. The side opposite or away from it is 11. And then we have 115 and we have 20 that are across from each other. Since I am finding an angle, we want to use this set of proportions, or set of ratios, excuse me, so that we have this angle is in the top this time. So I'm going to have, using my pink highlights here, I'm going to have the sine of B, that's my missing, so I'm going to have the sine of B over the side length opposite of it, which is 11, equals angles on top, so I got sine of 115 divided by 20, which is my side length. Again, the reason that I put my missing sine of B in the numerator is now all I have to do to get sine of B to start with by itself is multiply both sides by 11. Those will cancel, and I'm left with the sine of B equals this whole mess. So we have 11 times the sine of 115 divided by 20. Okay, so we learned in class already, again, I should have scooted that 11 times the sine of 115 over just a little bit. To undo the sine of B, we are just going to do the inverse of sine. Okay, so that will get rid of my sine, so I'm going to have B. I don't really have room over here. I should have had more room. B, our sine is gone, is going to be the inverse sine of this whole mess. We're going to have 11 times the sine of 115 divided by 20. Again, I can't stress this enough. I want you to make sure right now you pause the video, go put that into your calculator and make sure that you are putting it in there correctly, because there's a lot of things that can go wrong when you're putting that much stuff in the calculator. So just make sure you have this inverse sine. That's the first thing. You want to make sure you're using, oops, gosh darn it. Make sure you are using the inverse sine. write that the first time, using the inverse sine, and that you are putting all of this in there correctly. And if you did it correctly, you should get that angle B equals 29.9 degrees. Okay, let's try one more. Okay, so this time, again, it wants us to find angle C. If we're finding an angle, we are going to use these ratios. Okay, so I have angle C, which is what I'm looking for, and the side opposite of it, which is 17. And then I have a 51-degree angle and the side opposite of it, which is 18. So I'm going to do my sine of C, oops, my sine of C, angle C, divided by the side opposite of it, which is 17. So those yellows equal, and in my green, I've got the sine of my angle. Again, just like in other trig, that angle is always attached to the trig function, so the sine of the angle divided by 18, because that's the side opposite of it. Again, the whole point in having the sine of C in the top was so that all we had to do is multiply both sides by 17, and those cancel, and we are left with the sine of C over here equals, and this time I'm going to be a little bit smarter about it. I'm going to put 17 times the sine of 51 divided by 18. Okay, so now, just like before, I don't want the sine of C, I want C, so I need to do the inverse. So I'm going to take the inverse sine of both sides. That gets rid of my sine, so all I'm left with is C over here. My inverse sine, when I put that in the calculator, very carefully make sure that you are using inverse sine and that you have the 17 times the sine of 51 in the top and divided by 18. And if you did it correctly, you should end up with that angle C is 47.2 degrees. This can be kind of confusing as you're first starting it, so please let me know if you have any questions.